Section 1.5, Order of Operations, Applications. A graphic company charges $90 per hour for the work of its most senior graphics artist, $30 per hour for the work of its production designer, all right, and $20 per hour for the work of a trainee. All right, a recent project requires 32 hours of work from a senior artist. Okay, so I'll finish reading, I guess. 11 hours from a production designer and 40 hours from a trainee. Write out a mathematical statement for calculating the total labor cost and then compute this cost. All right, so we're going to say the number of hours worked for the, we're going to start with this 32 right here. Choose a different color. All right, so we're going to use this right here, this 32. So it's 32 hours, the number of hours worked, times this, the person is a senior artist. Well, what does that mean? Well, senior graphics artists make $30 per hour, right? Senior graphics artists make $90 per hour. The most senior, right? All right, so we're going to multiply that by 90. Then, let's see, what else do we have here? Now we want to now it says they're going to be 11 hours from the production designer, right? Well, who's the production designer? Where do we find that? 30 hours. This is where I messed this up, sorry. This is 30 hours from a production designer, right? So what we would do is we would multiply 11 hours by the amount that they make per hour, which is $30, all right? So far, so good. We have one more here. And we are going to add in. Now we have 40 hours of work from a trainee. Well, how much does a trainee work, right? Well, a trainee is that last one that gets paid $22 per hour. So we say 40 multiplied by 22. Okay, so it looks like we set up the equation. Awesome. So that is the mathematical statement for calculating the total labor cost. And then we're going to compute the cost. Okay, so we multiply 32 by 90 and we get 2,880. We multiply 11 times 30, we get 330. We multiply 40 times 22, we get 880. And when we add all those together, we get $4,090. So in the Olympics, County B ended up with the most total medals. The country A won the most gold medals. This created a controversy over which country had the best overall performance. One way to objectively settle this issue is to score the medals much like a high school or college track meet. That is, award 5 points for gold, 3 points for silver, 1 point for bronze. Determine a score for each country based on which point system, according to which scores which country won the Olympics. All right, cool. All right, so country A. Now, they said right here that we are going to we're going to have 5 points for gold. We're going to have 3 points for silver. And we're going to have 1 point for bronze, all right? So the first one's going to be, this is going to be times 5. This is going to be times 5. And this is going to be times 5. And this is going to be times 3, times 3, times 3. And this is just going to be times 1, times 1, times 1. And then you're going to add those together and then put the results at the end. Okay, so first we're going to do multiplication, and then we're going to add. Okay, so first there's 5 times 50, which is 250. Then there's 19 times 3, which is going to give you 57. And there's 25 times 1, which is just 25. Next you say there's 34 times 5, which is 170. And then it's going to be 37 times 3, which is going to give you 111. And then we are going to say 32 times 1, which is just 32. I know my handwriting's kind of bad. I have trouble reading it too. So just do your best. All right, so 34 times 5 is 120. And I'll try to do better with my handwriting. And then 22 times 3 is 66. And then we'll say plus 25, like that. Next step is we're going to add all these together. And you're expected to do these in your calculator. I just want to point out that you are expected to do the multiplication first. and then the addition second. So just be very careful to do the correct order of operations. PEMDAS still, right? PEMDAS. Multiplication before addition. Okay, so after adding these together, we end up with 332, 313, and 211. So it looks like the first one, country A, had the highest, won the Olympics, according to this weighted kind of a metric that they use there. So a particular model of automobile is rated by an agency as 22 miles per gallon for a city driving and 32 miles per gallon for highway driving. How many gallons of gas would the car consume during 154 miles of city driving and 192 miles of highway driving? Okay, so we take the number of miles driven within the city. We would multiply the city driving one here, so I can kind of color code this. Hopefully this will help with seeing what I have here. So you take this 22 miles per hour here, and you multiply it by the city driving, right? So you multiply the number of miles driven in the city by the cost of miles per gallon. Now, this is actually per mile. I'm going to make this a little more complicated, and then I'll try to simplify it. So that's that many miles, city miles, right? And we can multiply that by, it only costs 1 gallon. I'm writing this out like with dimensional analysis or unit cancellation. You don't have to do this. I'm just trying to point out this is kind of the logic of what happens, right? Okay. The point being is that these miles cancel out and you're left with gallons, right? So for every 22 miles, it only costs you 1 gallon driving within the city. So you really take the 154 and you divide it by the 22. So after cancellation, that's what it would look like. Okay, so I'll explain more of dimensional analysis when we get unit conversions later on, but right now, just an intro. You don't have to know how to do this yet. The next step hopefully will kind of explain it. The next one is there's 192 miles that you're doing in highway driving. And highway driving is even more. Basically, again, I'm just asking you to divide it. This is what the first one is how you would look if you did dimensional analysis. This is the way we just think of it here, where you say, oh, 192 divided by 32, which is probably the way you want to do it right now. And then that would spit out the number of gallons that would cost you, right? So the blue would be the number of gallons that it costs you to drive within the city, and the red would be the number of gallons that it costs you to drive outside of the city. So at this point, you're just going to use a calculator. You're going to say 154. Let me write this simplified form. Okay, so it's going to be 154 divided by 22. So 154 divided by 22 is 7, and 192 divided by 32 is 6, and 7 plus 6 is 13. So it costs 13 gallons. Now, if you intuitively understand how to divide, don't worry about it. But later on, we're going to do dimensional analysis, which is we're going to include the units, and the units themselves are going to cancel out, revealing what the final unit is going to be, and it will also tell us whether we set up the equation correctly. So I'm going to use dimensional analysis later on for some of the more difficult problems, but if intuitively you kind of understand how to set that up, that's fine for now. We'll get to that later.